So today we're going to talk right triangle trigonometry, and in terms of just triangles. What we've done before is we've related our right triangle trig to the unit circle, but today we're just going to solve sides of triangles and angles of triangles. So let's look at this first example here. We want to find the value of x, and we're given relative to this angle, we're given an opposite side, and we need to find the hypotenuse. So the opposite and the hypotenuse, that's sine of 40 degrees, is equal to the opposite side, 2000, over the hypotenuse, which is the unknown. We're going to multiply by x and divide by sine of 40, so x is equal to 2000 over the sine of 40 degrees. Make sure now that your calculator is in degree mode, so we'll take and go to mode. Notice we're in radian. Go over to degrees. Hit that. You're going to have to be conscious of whether it changes or not. And take 2000, divide that by the sine of 40. And we get an answer of roughly 3111. Alright, moving on. I want to find A, B, and C in this. Typically a direction for this problem would be solve the triangle, because they're asking you to solve for every missing part. First thing I can do is solve for either A or B, whatever angle I wish. And again, let's do this in degrees. So we'll take and let's solve for B. If I want to use B, I have its opposite and its adjacent. So I could say the tangent of B is equal to the opposite over the adjacent. In order to find B, I'm going to need to take the inverse. And I'll use a calculator for that. So in this case, I'll take and say the inverse tangent of 1 divided by 3. I'm already set in degree mode, so this will pop out 18.43 degrees. If I want to find angle A, I just take 90 minus 18.43, and that's going to give us 71.57 degrees. So now I have A and B, and I'm looking to find side C. I could just use Pythagorean theorem because it's a right triangle. So that's 1 plus 9 is equal to C squared. C is equal to root 10. It's that easy. Now we'll have some application problems, which are going to require drawing an accurate picture or a relatively accurate picture. We've got a radio operator makes a 75-foot vertical tower for his antenna, and the angle of elevation to the top from a point on the ground. Angle of elevation means if you were to take and look up from the ground, that angle created is your angle of elevation. We'll call this theta. And we want to know if I'm 50 feet from the 75-foot tower, what's that angle? Well, that's a pretty basic ratio. I have the opposite, I have the adjacent, so tangent of theta is going to be 75 over 50, or 3/2. So theta will be the inverse tangent of 3/2. Again, let's use degrees, so we're already in. And that's going to give us approximately 56.3 degrees. So in this next example, we see we're talking about something called an angle of depression. And we're talking about a lighthouse that's 250 feet off the water. And there's a boat 2 miles away. Now, angle of depression from, let's say, the top of this lighthouse, angle of depression is taken from a horizontal line of sight. So when we talk about making a right triangle, the angle of depression isn't in the triangle, it's actually outside the triangle. However, we know that this line up here is parallel to this line down here. Therefore, by alternate interior angles, we can say theta is equivalent to this angle down here. And that's what we're trying to find. So this angle of elevation, if you will, is equal to this angle of depression. Now, in order to find these values, we're going to have to take and have the same units. So this is 2 times 5,280 feet, which is equal to 10,560. So now I use my ratio of tangent, it looks like. It's equal to the opposite, which is 250 over 10,560. And then I'm going to have to use an inverse once again. So theta is equal to the inverse tangent of 250 over 10,560. And that value for theta is actually pretty small. It's about 1.36 degrees. Let's take a look at the next example. So we've got a woodcutter wants to try to find the height of a tree, stands a distance from the tree, and measures the angle of elevation to be 40 degrees. Then he moves 30 feet closer, looks up again, and finds that the angle of elevation is now 50 degrees. And we want to find out the height of the tree. Well, we can do a couple of things here. I think probably the best thing to do would be to find some ratios for each of the two triangles made. So let's look at the small triangle first. I know that the tangent of 50 equals y over x. And then in the second triangle, I know that the tangent of 40 is equal to y over x plus 30. So now you'll notice I have two equations, two unknowns. I can use a set of substitution. So y will equal x tan 50 and y will equal tan 40 times x plus 30. And since both of them are equal to y, I can set the two equal to each other. So x tan 50 is equal to x tan 40 plus 30 tan 40. I just went ahead and distributed. I'm going to bring all the x's to one side of the equation. So x tan 50 minus x tan 40 equals 30 tan 40. Factor out an x. Get tan 50 minus tan 40. Set that equal to 30 tan 40. Divide, so x is equal to 30 tan 40 over tan 50 minus tan 40, which is equal to 71.38. Now, once again, that's the x value, and I'm looking for the y value. So I know y equals x tan 50. So if I take 71.38 and multiply it by tan 50, I get roughly 85.07. And that is my y value. So let's talk about another set of definitions. I'm going to talk about something called cofunctions. And by definition, the values of sine and cosine, secant, cosecant, tangent, and cotangent are all called cofunctions. And there's a complementary angle theorem that states cofunctions of complementary angles are equal. So if I take 10 and 80 degrees, which are complementary angles, and take their cofunctions of those, so sine and cosine are cofunctions, these two values will always be equal. And again, it goes on to give you those theorems written out here, where we have 90 minus angle measures, in each case equaling the cofunctions. If I take and ask you to evaluate this expression without using a calculator, because we don't know the secant of 43 and we don't know the cosecant of 47, but I know 43 and 47 are complementary, and I know secant and cosecant are cofunctions. So these are cofunctions of complementary angles. Therefore, the secant of 43 equals the cosecant of 47. Therefore, this equals 1. Pretty straightforward. Now, next we'll talk about something called bearing. And bearing is a way to measure angles, except bearing is measured from the north, and it's measured in a clockwise fashion. So this is the best picture of this. Now, another way of stating bearing, and in this picture to the right, we have a bearing of 241 degrees, and that's from the north. Another way of stating bearing is in this directional fashion, in other words, south 34 degrees east. What that means is start at the initial direction, south, and then go 34 degrees to the east. So that's another way of stating bearing, where you start, how many angles or how many degrees you move, and in which direction you move towards. So let's do a problem involving bearing. A boat leaves from the port of Boston, and it has a bearing from Boston of south 80 degrees east. So here's my 80, and this is 10, and it's going to travel at 10 miles an hour, 10 knots for an hour. So this length actually is 10. Then it's going to take and make a 90-degree turn towards the southwest. So if I go 90 degrees, that means it makes a right angle. The southwest is this direction, and that's 90 degrees. What I'm going to do, just to make life easy, is create a new axis. I'm going to draw some things in. So I know that if this was 10 degrees, this is 80 degrees. And I know that this length is 10. I know this green length, since it goes 2 hours at 20 knots, is 40. And I want to know, after that 2 hours, how far am I in bearing from Boston? So I want to know this new angle from Boston. So that means I'm going to need to find probably this angle here in order to find this angle here. So I'll use a tangent calculation. I'll say, and let's call this x. Tan of x is equal to 40 over 10. So x equals the arctan of 4, which is about 75.96 degrees. So that's this green angle here. In addition, I have 10 degrees added to that, so plus 10 is 85.96 degrees. So therefore, this angle is the remaining amount, which is about 4.04 degrees. So in order to state that, from Boston, I go south 4.04 degrees in the easterly direction. And that's my bearing. That's all we've got with our right triangle trig. Write out your lesson summary, do my math lab, and we'll see you tomorrow.